Today I'm going to talk about the Gorilla GRF2111, which is a low noise broadband LNA. 2111 is a one-stage LNA in a DFN6 package. It has a V-enable pin, so you can control the bias current by adjusting the bias resistor that's on the V-enable pin. The part is extremely broadband. We only advertise it as an X-band LNA, mainly 8 to 12 gigahertz. But from working with the device, I know that it can work from about 5 gigahertz all the way up to almost 13 gigahertz. And that includes gain, power, and maintaining linearity across that whole band. Matching for the 2111 on the input, we have really close to pin 3. We have 2 shunt 0.2 picofarad capacitors. And the reason we do this is because we're using 0201 components to match the part. And we need a 0.1 microfarad shunt cap, but since they don't make a 0.1 in 0201 size, we use 2 series 0.2 puff caps. And that input shunt component near the pin basically extends your gain. If you want to have good gain flatness above 10 gigahertz, using those shunt capacitors is a must. So we include them on our BOM as a standard component. The output of the 2111 on pin 4 utilizes a shunt capacitor as well, and we use a 0.2 picofarad at that point. Our board doesn't allow for it, but ideally you would do 2 in series to have a 0.1 picofarad capacitance right on the output pin. And what that does is that gives you the output power of 20 dBm or greater for your P1 dB. And that is pretty much across the whole bandwidth. And it really rolls off hard once you get above 12 gigahertz. You can have about 20 dBm of P1 up to about 20 gigahertz. Once you go above, 12 gigahertz. Once you go above 12, it begins to roll off, and maybe around 12 and a half to 13 gig, you might have 16 to 18 dBm, which is still good power, but it's beyond the spec of the part. Okay. Yeah. With the 2111, one of the downsides that we've experienced so far is customers don't complain, but they say it doesn't have enough gain, and they wish we had a 2-stage version of this part. Well, I have 3 customers that I've worked with over the last year who we gave them data on cascading 2 2111s together, and the performance is really nice. You can get above the 20 dB of gain that a lot of people are looking for. The native single 2111 has about 13 to 14 dB of gain across the band. Well, when we cascade 2 of them together, we can achieve somewhere around 22, 23 dB of gain with whatever losses are incurring. And I have 3 customers who've integrated into their platforms the cascaded 2111s, and it seems to perform really, really well. The gain flatness for the 2111 is very flat. I would say it's from 8 to 12 gig, you probably have about a dB or dB and a half of delta. If you take it all the way down to 5 or 6 gig, all the way up to 13 gig, it's almost the same. You probably have about 2 or 3 dB of gain delta across that whole band. So it holds up very nicely for broadband. I don't think this is a good part if somebody wanted it to have a narrowband S21 response. Return loss wise, the S11 and S22 are better than -10 at all in all the X-band areas. We've optimized the return losses And these are things that we learn over time as we tune and get requests for different customers that demand different performance requirements. We've learned to do simple matching changes as time goes on to improve return losses on both the input and the output. The over temperature, the GRF2111 is very typical of our other products. Like always, there's a delta as you go from -40 to +85, but the delta is totally in line with our other products, and there's nothing surprising about the increase or degradation in performance as you go from cold to hot. I have not seen any stability issues with the 2111. It's very stable. The mu is always above 1. The noise figure for the 2111, the de-embedded noise figure is around 1 from 8 all the way up to 12 gig. And maybe right at 12 gig and a little bit higher, it starts to skew upward to 1.1, 1.2. But the noise figure on this part is excellent. The only downside to the 2111, I think, is the gain. A lot of customers want a higher gain solution, and so far, cascading them in a series has satisfied anybody who's come along. Just because the performance of this part, I think, merits the downside of buying 2 of them. In the meantime, I know for a fact that we are trying to develop internally some new versions of the 2111 that are 2-stage. But with that will come the challenge of interstage matching, and interstage matching can do all sorts of squirrely things, especially at high frequency. So most likely the interstage matching will be inside the package or on die. Highly doubtful it'll be on the board. I guess the 2111 could be more linear. The linearity is in the mid to lower mid 30s. I think that for output IP3, I think some folks might want that to be higher, but I think for a broadband game block, that's actually pretty typical and well within what you'd expect.
Thank you so much for watching. If you'd like more information, please email us at sales@gorilla-rf.com. And don't forget to subscribe to our channel for more content from Gorilla RF.